Hi everyone, today I'm going to analyse and present a solution to a mathematical problem which provides an environmentally sustainable approach to transport. This presentation supports the idea that by calculating the amount of CO2 emissions released by each form of public transport versus driving a car, the most environmentally friendly form of transport will be identified. By doing this, it gives people the information they need to make an environmental choice when choosing transport to lower their environmental footprint. When faced with a mathematical problem, it is important to first gather relevant data that could help you to understand the problem and demonstrate reasoning in developing a correct and effective solution. I've developed some questions to consider in the form of a mind map to help start to understand all parts of the problem that need to be resolved. This presentation identifies that carbon emissions is becoming a big problem with impacts on our environment in the form of climate change and global warming. This is why I've chosen to develop a solution to the rising problem of CO2 emissions released by different types of transport. By the conclusion of this presentation, data evidence will be presented to identify which form of transport emits the least amount of carbon emissions per passenger kilometre. To begin to understand the problem, it is first important to understand what carbon emissions actually are and how they are produced. So every time fossil fuels are burnt, such as coal, gas or oil, carbon dioxide is released into the atmosphere, and this becomes part of the natural cycle of carbon. So what is the carbon cycle? The carbon cycle is how carbon, in all of its various forms, moves between plants, animals, the ocean and the atmosphere. The graphic shows how carbon moves. Carbon is released into the atmosphere during the burning of fossil fuels. This carbon is absorbed by plants, along with the sun's heat as a source of food. This process is called photosynthesis. Once plants have died and decayed into the earth, over thousands of years it may become fossil fuels such as coal, gas and oil. Then the natural cycle begins again with the burning of fossil fuels. So what is to blame for this increase in carbon emissions? The main contributors to the rise in carbon emissions are transport, electricity generated, heating and other burning of fossil fuels. Due to the rise in the world's population to 7 billion people in 2014, there are more people living, working, travelling and using energy produced by burning fossil fuels. This has seen the amount of carbon emissions released per year spike to dangerous new heights. So now that you understand what carbon emissions are and the effects transport is having on our environment, you can now see how critical it is for things to change. We must develop ways to reduce our carbon footprint, and to do this we must first identify how much carbon dioxide is released for different forms of transport so that we can make informed decisions on how to reduce this amount. To solve this problem, we need to look at the information we are provided with. Researchers have found that one tram emits 60 grams of carbon dioxide per passenger kilometre, with an average tram holding 20 passengers. To work out how much carbon dioxide a tram releases per kilometre, you have to multiply the amount of carbon dioxide released per passenger kilometre, which is 60 grams, and multiply it by the amount of passengers on an average tram, which is 20. This will form the equation 60 times 20. It helps when multiplying an equation to form a simpler problem by breaking the equation down. So we know that 0 times 0 equals 0. So you place a 0 in the units column. Now move to the tens column. 2 times 6 equals 12, so place a 12 in the tens column. Because we are multiplying by tens, the rule says that we must place a 0 at the end of the solution. So it is 60 grams of carbon dioxide per passenger kilometre times 20 passengers gives you the amount of carbon emissions released by each tram per kilometre. The answer is 1,200 grams of carbon dioxide released per kilometre travelled by tram. This is compared to 5,000 grams of carbon dioxide released by cars if all 20 passengers decided to drive their own cars to work, opposed to taking public transport. To create this solution, we must do a multiplication to work out how much carbon emissions are produced per kilometre when travelling by car. To compare this with a car, we must do the same equation to solve how much carbon dioxide is released by the same amount of people if they decided to drive to work instead of taking the tram. We must use the relevant information we have been provided with. Researchers have found that one car releases 250 grams of carbon dioxide per passenger kilometre. We know that for every passenger kilometre travelled by a car, 250 grams of carbon dioxide is produced. To find out how many CO2 emissions are produced by 20 cars, we must multiply 250 grams by 20 cars, creating the equation 250 times 20. Again, when trying to multiply an equation, it is helpful to simplify them into smaller equations. We already know that 0 times 0 equals 0 from the previous equation, so we can cross off both the zeros, making the simpler equation of 25 times 2. And we can work out that 25 times 2 equals 50. Because we are multiplying by hundreds, we must place 2 zeros at the end of the product, making the answer 5,000 grams of carbon dioxide released by 20 cars per kilometre. So to now work out how much CO2 is reduced by choosing to travel by tram to work opposed to driving by car, we have to subtract the amount of CO2 produced by 20 cars minus the amount of carbon dioxide produced by a tram carrying 20 passengers. This creates the equation 5,000 minus 1,200. When subtracting, we start in the units column, subtracting 0 from 0, which equals 0. We then move to the tens column, again with 0 minus 0 equaling 0. When moving to the hundreds column, we come across a problem. 2 cannot be subtracted from 0, so we need to borrow from the thousands column, making the 5 a 4 and the 0 a 10. So 2 can now be subtracted from 10, equaling 8, and 1 can be subtracted by 4, making it 3. The equation equals 3,800 grams, which is how much CO2 emissions will be reduced if 20 people decide to take a tram to work opposed to driving 20 individual cars. This bar graph represents the two different data representations found to clearly identify the reduction in CO2 emissions found if people choose to take trams to work versus driving a car. The bar graph displays the data found that 20 cars release 3,800 grams or 3.8 kilograms of carbon dioxide more than if all of these 20 people decided to travel to work by tram. Its mathematical problem presented is, are cars or buses a more environmental form of transport? Researchers have found that one bus that carries on average 34 passengers emits 40 grams of carbon dioxide per passenger kilometre. The same exact principle applies to work out how much carbon dioxide a bus emits per passenger kilometre multiplied by how many passengers it would hold on average, which is 34. The equation is 40 times 34, which equals 1,360 grams of carbon emissions released per kilometre. At this amount with possible 34 passengers deciding to drive their own cars to work, we must first solve the problem of how much carbon dioxide would 34 cars emit. This is solved by multiplying the carbon emissions released per passenger kilometre by 34 cars carrying one passenger each, creating the equation 250 times 34 equaling 8,500 grams of carbon dioxide released by 34 cars per kilometre. To measure how much CO2 would be reduced by people choosing to catch a bus opposed to driving their own car, the amount of emissions released by 34 drivers must be subtracted by the grams of carbon released by a 34 passenger bus, creating the equation 8,500 minus 1,360 equaling 7,140 grams. This is the amount of CO2 emissions that would be reduced if an average bus load of 34 passengers decided to take the bus to work opposed to driving individual cars. cluster column chart represents the two different data representations found to clearly identify the reduction in CO2 emissions found if people choose to take the bus to work opposed to driving a car. The chart is a visual aid that helps see the reduction in an easy-to-read format. To clearly determine which form of transport is more environmentally friendly, we must also analyse the carbon emissions of a train compared to driving a car. One average Metro two-carriage train carries 100 people, producing 230 grams of CO2 for every passenger kilometre. To determine how much CO2 emissions are produced by a train carrying 100 people, you have to multiply the carbon emissions produced every passenger kilometre by the average amount of passengers travelling on the train. The equation is 230 times 100, equaling 23,000 grams per kilometre. As this number is very high and hard to interpret, we need to convert it to a smaller number. To do this, we need to round it to kilograms. To convert grams to kilograms, you must divide the grams by 1,000. So 1,000 grams goes into 23,000 grams 23 times, converting it to 23 kilograms per kilometre. The same principle applies for identifying the carbon emissions produced if these 100 people decided to travel to work by car instead of train. The equation would be 250 times 100, equaling 25,000 grams of carbon dioxide produced per passenger kilometre. When working out an equation, it is important to keep all units of measurement the same. So if you convert one part of the equation, you must also convert the other so the units of measurement are the same and the solution is correct. So in this case, we must also convert the grams to kilograms. So the equation would be 25,000 grams divided by 100. 100 is divided into 25,000 grams 25 times, converting the answer to 25 grams. Calculate how much carbon dioxide is reduced per kilometre travelling by train opposed to driving a car. We have to subtract the amount of carbon emissions released by 100 cars per kilometre compared to the emissions released per passenger kilometre on a train that carries 100 people. The equation would be 25 minus 23 equaling 2. The product of the equation shows if 100 people decide to travel by train to work opposed to driving individual cars, 2 kilograms of carbon dioxide will be reduced per kilometre. This bar graph represents the two different data representations found to clearly identify the reduction in CO2 emissions found if people choose to take a train to work as a form of public transport opposed to driving to work, displaying the reduction of 2 kilograms of CO2 if travelling by train per kilometre in a simple visual format. This pie chart clearly represents the results that bus is the most effective form of transport, releasing the least amount of carbon dioxide per passenger kilometre. The 0% in this pie chart also represents the amount of carbon emissions a bike emits per kilometre, making it a great form of transport, but in this case it is not a form of public transport. By using the solution to the mathematical problems we have developed, we can use this information to make an environmentally sustainable choice about which form of transport to take to lower our environmental footprint. To sum up the findings, this presentation has concluded that travelling by bus saves the most carbon dioxide when compared to all the other forms of transport. Yet riding a bicycle or walking to your destination has proved to release no carbon emissions, making it the most environmental and sustainable choice you can make when choosing a form of transportation.